Hello guys, in our last lesson we learned about the cis-trans isomerism. We know if you have a carbon-carbon double bond and if each carbon atom attached here has different groups attached, it can show the geometrical isomerism, right? If the groups attached here are different to each carbon atom, then it will show the geometrical isomerism. In our last lesson we learned how to assign the cis and the trans terminology, right? Suppose here we got the hydrogen atoms on the same side of a double bond, we call it as a cis. And if these similar groups, hydrogen, hydrogen, chlorine, chlorine, if these are on the opposite side, we use the trans terminology. But what if you have a molecule where each carbon atom has different groups and all the four groups are actually different, right? So we cannot use the cis and the trans. We cannot, because you cannot compare. You don't have the similar groups to compare to use the cis and the trans terminology. So for this type of a molecule, if you have a carbon attached with the fluorine, iodine, carbon, chlorine and the bromine, now we cannot use the cis and the trans terminology for these type of geometrical isomers. Why? Because we don't have something similar to common. For the cis and trans isomerism, we need to have something similar attached to the two double bonded carbons, right? But over here we don't have anything similar, right? So therefore we cannot use the cis and the trans terminology for this type, for the geometrical isomers of this molecule. Rather we use the E and the Z terminology, right? And how we assign the E and the A and the Z terminology? The first thing is that we assign the priority to the groups attached to the carbon atom. To the each double bonded carbon, it has two groups, and we will assign the priority to the groups. And the priority is assigned on the basis of the CIP rules, right? That is, an atom with the higher atomic mass will have a higher priority. Like suppose we have an iodine and the fluorine. Among these two groups, iodine will get a number 1 priority and the fluorine will get a number 2 priority, because iodine has the higher atomic number, right? So higher atomic number means the higher priority. Now looking at this carbon, it has got two atoms, chlorine and the bromine. Bromine has higher atomic number, so it gets the number 1 priority, and chlorine the number 2. And after that we check whether the highest priority groups are on the same side or they are on the opposite side. If the highest priority groups are on the same side of a double bond, we use the term Z. If they are on the opposite side, suppose you have a 1 here, iodine is here, and now we will get on the opposite side the highest priority groups, then it will be called as an E isomer, right? So that means this molecule here, it has the highest priority here, second one this one, first one this, second one this, so this will be a Z isomer, right? And I can draw another geometrical isomer for the same molecule. Let me write down the iodine here and the fluorine here. Now in this molecule, you see the highest priority groups are on the opposite side of a double bond, so this will be called as an E. We use the E terminology when the atoms or the groups of higher precedence are on the opposite side. We use the Z terminology when the groups or the atoms of the higher precedence are on the same side of a double bond. Pretty simple. Let's take a few more examples here. Look at this molecule. We got a carbon attached with a methyl and the hydrogen. And obviously this particular methyl will get a number 1 precedence over the hydrogen, because carbon has higher atomic number than the hydrogen. Now about this carbon, it is attached directly first with the CH2 here. So now there is a tie. We cannot actually check which has the higher priority by looking at this one, because CH2 and the CH2, the atomic number is same. Now looking at another carbon and another atom, it is CH2 and CH2 here again there is a tie. Now look at this one, the third one. Move on to the third one. Now it is fluorine, and here you have got a carbon. So fluorine has a higher atomic number than the carbon. Therefore, this whole group will get a number 1 priority, and this one will get a number 2 priority. And now we can see whether the highest priority groups are on the same side or on the opposite side. Here you see in this example, these are on the same side, so this will be a Z isomer. Let's take one more example. In this molecule, you see this is a methyl group CH3 here, and chlorine has a higher precedence than the methyl, Over here it is the bromine, because you got here the CH2 and the CH3. Bromine has the higher atomic number than this particular carbon, so this one will be a number 1, and this whole group will be a number 2. Highest priority groups are on the opposite side, so this is an isomer. Let's take this molecule, methyl and the hydrogen. Again, the methyl the number 1, hydrogen will be the number 2. Over here we have to just look at this molecule carefully. Okay, so in this case we got the first carbon attached to the double bonded carbon is the carbon. Here you again have a carbon, right? But now after that it is the 2 hydrogens and the 1 carbon, right? That means this particular carbon is attached with 2 hydrogens and the carbon atom. Now this particular carbon over here is attached with 3 carbons. Okay, the situation is like this. Here you got a tie, first thing is tie, but then we have to see what are the groups attached to this particular carbon. It is 2 hydrogens and 1 carbon. Here in this case it is 3 carbons. So 2 hydrogens and the 1 carbon. Here in this case 3 carbons. So obviously this group will get a number 1 priority, right? So this group will get a number 1 priority than this one. We don't have to look at the oxygen, it has a higher atomic number, but that comes later, right? When we are assigned the priority, we have to see the first point of a difference in the group. Correct? The first point of difference is over here. So therefore, this one you can see here the highest priority groups are on the opposite side. So therefore this will be the isomer. Alright, let me write down another molecule here. You can see we got, suppose, a methyl and a hydrogen, the C double bond OH. Here in this case methyl has the higher priority than the hydrogen, so number 1 here, this is the number 2, and C double bond OH, and this is the CH3. Now you got here the first thing is we have to just look at the atoms attached to the carbon. Here is carbon, here is carbon, so that is there is a tie. But then we have to look the atoms attached to this carbon is oxygen and the hydrogen. Here you got the 3 hydrogens, but here is oxygen, right? So therefore this group will get a number 1 priority than this one. Highest priority groups are on the same side, so this will be a Zisomer. Hope you got it. Thanks for watching the video. Bye for now.